In this video, we will look at caching as a possible cause for memory leaks and how we can detect them and even possibly fix them. Hi, I'm Rohan, and this video is part of a series of videos where we are exploring how JS manages its memory in depth. More specifically, looking at various use cases that are the common causes for memory leaks and how we can understand and avoid these types of coding patterns. So let's get to it. Let's discuss how caching can often cause memory leaks if not handled properly. We often need to cache. For example, when we have lots of data coming from an API, especially if the data doesn't change much. The problem arises when we keep adding data to the object that we consider as our cache without removing objects that are unused or objects that we assume are already removed but a reference still exists in our cache. So we need to be careful here, otherwise the cache grows indefinitely. Hence, we need to manage the clearing of the cache object somehow when we don't need some of the data within it. Otherwise, we would have a memory leak to deal with. Let's look at an example. Here we have a list of users which we will fetch from an API. We will show this as an unordered list in our app and we will also cache it. If we click on any of the list item, then it should delete the user. So far it's straightforward, right? Okay, so we have a simple Express Node.js server exposing three APIs. The first API is our client HTML page. The second API is to get all the users. Of course, for now, it's just dummy data from a JSON file. And the third API is to delete a user using its ID. So we come to our client page. Here we have a simple HTML file containing an unordered list tag and a script tag. In the script tag, we have an immediately invoked function expression so that nothing accidentally persists in the global scope. Inside this, we have a class called user service, which is responsible for fetching the users and caching them and deleting a user. So in the class, first we have a private property, user element user cache, which is a map which contains key as the user item element and the value as the user object. A getter property user elements that exposes all the keys of this map. Then we have a private method create element which accepts a string parameter content. Inside create element, we will create an li element and after that we will assign the text content of this element with the parameter content. After that, we will add an event listener for the click event on the element which will call delete method with element as the argument. We will define this method in a moment and then we return the created element. Next, we have a method called get. In this, we use the fetch API to get all the users from the backend. We read the response as JSON and then we loop through it. For every user, we create a list item element by calling create element with user's first name, last name and email as the content. We add this created user element as key and user object as value in our cache. Next, we will define delete method, which will accept user element as a parameter, which is a list item element. Inside this method, we will get the user object from the cache using user element as the key. We will then use fetch to call the delete API with user.id and then remove the user element from the DOM. Outside the class, we will get user list element from the document using get element by id. After that, we will create an instance of user service. Then we will call user service.get to fetch all the users and we will replace all the children in the user list element with user service.user elements. Let's start the server and open this in the browser. Open DevTools and then go to the performance section. Then we will click on the refresh icon, which will refresh the page and record the first 5 seconds of the page's performance. We will notice immediately that right after the page is loaded, there is a bump in the CPU and memory usage. And after some time, the memory is cleared a bit, but not as much as it was when the page was loaded. This is because when we load the page, then we fetch a lot of users and then we render them in the UI as list items. After that, a major garbage collection cycle happens which clears up some memory. Till here, everything is as we expected. The net heap chart won't tell us much. So we will go to the memory section to find out much more about this. Select heap snapshot and click on the record icon. We will record a bunch of heap snapshots while we are clicking on the list items in between the recordings. Let's click on the first snapshot and we will see that we have lots of HTML li elements. Also, if we filter for user service and then expand it, we can see that we have the cache map with HTML li element as key and user object as value. So far so good. But if you remember, after the first snapshot, we clicked on the list items, which in turn deleted them. So let's select the second snapshot, filter for user service, and then expand it. We can see in user element user cache, we have lots of detached HTML li elements as keys. Same is true for the rest of the snapshots, but the number of detached elements is increasing. This is what we were looking for. This shows that even though we have removed the HTML li elements from the DOM, they persist in the heap memory because their references exist in the map as keys. So this is a memory leak. Let's fix this. So we go back to the code and focus our attention on the delete method in user service. Now, you might be thinking to yourself that the most simple and obvious solution is to add a single line to delete the entry using user element from user element user cache. And you are absolutely right. That's an excellent solution. But in our case, I don't want that. I specifically want to use weak map here in place of map. Now, what's the difference and why do we want to use this instead of map? After all, it will work just fine when we add a line to delete the entry. The thing about weak map that we are so interested in is that it holds the references to the keys weakly. What do I mean by that? Let me explain. Suppose we have an object that we are using as a key in our weak map. Now, at some point in time, all the references to this object are removed except for the one that exists in our weak map. So, when there is a garbage collection cycle, this weak map key will be garbage collected and the corresponding value will be deleted from the weak map. If this value is not strongly referenced elsewhere, then it will also be garbage collected eventually. Also, unlike map, we can't access keys, values and entries of a weak map. Neither can we iterate through it. These are interesting quirks of a weak map. By the way, weak set also works quite similarly. It holds references to the objects weakly. Anyway, we come back to our code and we change user element user cache from map to a weak map. We also remove the getter user elements since we can't fetch the keys anymore. Now, since we can't get user elements, we cannot use replace children anymore. So we remove that line. Furthermore, we will change the get method in the user service to accept a new parameter add element, which is a callback function that we will call with user element as an argument after user element and user object is set in our cache. When we call the get method outside, then we are going to pass it an arrow function as an argument that will accept element as a parameter and add this element as a child to user list element using append child. Now let's save the changes. And if we notice, then our code is much more efficient than before. Let's restart the server. Open this page in a browser, open DevTools and then go to the memory section. Select the heap snapshot and we will record several snapshots. In the meantime, we will start clicking on the list items in between recording the snapshots. Let's click on the first snapshot. We will see that there are lots of HTML li elements. And if we filter for user service and expand it, then we can see that user element user cache is now a weak map. So far, it's as we expected. Let's select the second snapshot and filter for user service and then expand it. We can confirm that there are no more detached HTML li elements, which is what we wanted. We can further confirm this in rest of the recorded snapshots. So to conclude, we need to be careful of the object references that we cache. There should always be a logic to remove the unneeded objects from our cache. To that effect, we should use weak map or weak set whenever it's possible. If not, then we should try to delete the unneeded entries at suitable intervals and as per our requirements. So to quickly summarize, we looked at caching as a source of memory leak using an example and how exactly we can fix it. If you have liked this video, consider liking and subscribing. Thank you for your time. Have a nice day. Namaskar.